the surface magnetism solver pins objects to other colliders. To demonstrate this, I'll first create a plane that will act as the wall against which we will send raycasts. I will then add the object that I wish to place. In this case, it's Van Gogh's Parsonage Garden in Spring. And I want to make sure that the mixed reality camera is also in the scene. And I've chosen the right profile as well. And once we've done this, then you will see how the painting will find a spot on the wall. So some of the important properties of this that I'd like to point out: the surface normal offset can control the distance from the surface that you're using. Under the raycast properties and magnetic surfaces, you can also choose the layer against which raycast will cause the solver to have an effect. A different result is easily found using the control array, and you can see that for handheld objects this is a much better solution. We can also turn this plane into a sphere. We want to make sure it has a sphere collider so that it can receive the raycast. The reason I'm doing this is to demonstrate the use of the orientation mode in the general properties of the surface magnetism solver. I'm going to choose surface normal, and at the moment we're still using the tracked target type as head because it was changed during play. And now you can see how the picture will stick to the surface of the sphere. Blending these together gives the kind of behavior that you might be more familiar with Microsoft's own user interface, albeit in a slightly more extreme form here. So that completes a very quick look at the surface magnetism solver. Now we're going to put the remaining two we want to look at together into a single project and try and make something a bit more useful. In this case, we will do a catapult.